Hello and welcome to BPUB's annual community tour. BPUB has always taken great pride in opening its doors to the community so that they can come and see what it is that we do here for the community. Unfortunately, COVID-19 had other plans for 2020, but we didn't want people to miss out. We still wanted to have some kind of tour, so we decided to make it virtual this year. Hope that you still find it educational and that it'll be enough to tempt you to sign up for the tour once it's offered again. First stop doesn't take you too far from your house, and that's your meter. Let's go to revenue recovery to learn about some of the dangers associated with meter tampering.
Welcome to the Revenue Recovery Department. My name is Ramon Lucio, and we got some things that we can show you today regarding meter tampering. Meter tampering can be defined as diverting the meter or disorienting the meter or water meter itself. What we have here is a solid state. Actually, it's a mechanical meter. It's a mechanical meter. This mechanical meter has been used for years within Brownsville, here in Brownsville. Okay, now we've been changing for a while to solid state meters, which is just pure wires inside. Okay, on this one, this is a new kind of meter that we have now. As you can see, there's a little display that goes here. This little display is covered by this area to where when the sun hits it, it will not fade away. So it will last for a long time. Okay. And here we have another solid state meter. This is for the RF meters, which is the ones that can be picked up on the street, by the street, and or by the corner of the driving by. You can pick it up with an itron. Okay. Some signs of tamperings that we look for out there is broken seals, magnets on the meters, any attachment on the meter itself, or also some holes on the objects trying to stop the disc from turning. Okay. Our frontline people that when they discover a tampering would be the meter readers and the servicemen, and maybe the customers also when they call the hotline. And the hotline number is area code 956-983-6381. The meter readers, what they do is every day they go out there at 7 o'clock in the morning. They go out there and read your meter, either water meter or electric meter. And they average about maybe 500 to 600 meters a day. Okay, that's what they do. And it's from 7 o'clock to 4 o'clock in the afternoon. Every day, Monday through Friday. So, and sometimes they work on the weekends also. And the servicemen, what they do, they disconnect, they reconnect their services, they get the get starts, which means when there's a new customer coming in on a location, which is a house or an apartment, they're the ones that do the inspection before you go into that house. So it would be safe for you to enter the house, and render services. Okay, meter tampering was common back when it started. It started, I think, if I'm not mistaken, back in 2007. Okay, and ever since it's been going. The numbers have been going down, because now they know that we're out there. So that's when people now most of the time they call in on the hotline. You know what? My neighbor has this going on. Can you come and check it? Or even the meter readers when they call us for a broken seal. So we go out there and check it out first, before we determine anything or thinking that they're tampering. The tampering fees run up from $425, depending on what it is. If it's the water, it's $425. The tampering fee has to be paid within 24 hours. Okay, we do a police report. We do charge them the $425, and we do a back billing. Okay, on the electric side, it's $435. And it has to be paid also within 24 hours. And we do the same process as the water. And we can go up to 4 years, depending on how we see that. The movement was to where maybe the consumption went high or went low. That's all we can determine. We had an incident back in, I could say when I started here. We had an incident, and this customer had a big house, maybe about 3,000 square feet. Okay, an average, I guess He was averaging real low on the consumption, so we went to go check it out. Okay, and in that case, this customer was tampering because he had some lines connected to our side. So he had jumpers. And then we recovered about maybe 15,000 from that customer. Yes, it's very dangerous. You can get electrocuted. You can actually die out of it, because it is very dangerous if you don't know what you're doing. And some people think it's easy, but it's dangerous. Thank you for joining us. And remember, to report any tampering, just call the hotline 956-983-6600.
That meter is what measures the amount of electricity that you use in your home. But how is that electricity generated? Our next stop should answer some of those questions. Let's head over to Silas Ray Power Plant.
Welcome to Silas Ray Power Plant. My name is Alonso Gonzalez. I'm the senior engineer here at the power plant. I've been here close to 20 years. This is the Silas Ray Power Plant. It was installed in 1948, and we've been installing generators almost on average every 10 years. So currently we have operating 3 turbines. We have our unit number 10, unit number 6, and our unit number 9. In combination of all these 3 generators, we have approximately 110 megawatts of available power to the city of Brownsville. Unit number 9 and unit 10 are basically jet engines. Unit number 9 is an industrial type jet engine, and unit number 10 is an aeroderivative jet engine generator, and unit number 6 is actually a steam turbine generator, which is in combined cycle with our unit number 9. So in combination of all these 3 generators, we have about 110 megawatts of available power for the city of Brownsville. And another thing is, all the energy we use here is natural gas. That's the fuel we have for our turbines. And we don't have any. We used to have diesel, and that was on unit number 9 only. And also another important part is we do have emissions controls on all the units, so we keep the emissions as required by the state of Texas in compliance for all the turbines. Another important thing on the power plant is that we are a black start for the state of Texas, and we have that mode of operation available for the city of Brownsville also. In case we need power, we can turn on our unit number 10 and provide power to the city of Brownsville. We have about 26 employees here at the power plant. We have an operator, 2 operators at the control room, 24/7, 365 days of the year. So there's people at the control room all the time in case the power is needed. They turn on the generators and turn them off as required. And we also have a crew of mechanics and instrument technicians that take care of the maintenance and preventive maintenance of the plant, correct? And also we have mechanical engineers as myself, and then another mechanical engineer, and supervisors, the maintenance supervisor and the operations supervisor, and of course the power plant manager. So a total of 26 employees here at the plant. The control room is basically is where all the information is gathered from the plant, from all the turbines. They have a monitoring system, what we call a distributed control system, in which they have monitors getting all the temperatures, pressures of the turbines at the different stages of the turbine, as well as the cooling equipment and all the auxiliary equipment that they have. So the chief operator is at the control room monitoring all those temperatures and alarms. And if there's something that looks kind of different or out of the ordinary, they can send a turbine operator to take care of it. Make sure they visually inspect the equipment, make sure there's nothing out of the ordinary, and they can take the appropriate action to correct it and make sure the generator is in operation. So basically, on the control room, they take care of the equipment and make sure it operates as intended. And the way it works is that we send the power through the lines that you see around the city, and those lines interconnect to all the substations that we have in the city, and from there they step down the voltage to the regular homes and businesses. So this power plant is actually interconnected to all the substations in the city, as well as interconnected to all the other substations from the other companies in Texas and NERCA in this case. Thank you for joining us today, and hopefully by next year we'll be able to invite you to our regular tours again.
BPUB is a member of the Electric Reliability Council of Texas, better known as ERCOT. Silas Ray is just one link in a greater chain of generation sources located throughout Texas that ERCOT balances to make sure that you have the power you need when you need it. Now that we know a little bit more about how power is generated, our next stop is going to get us just a little bit closer to that energy arriving in your home or your business.
Welcome to the community tour. My name is Lutz Sippel. I work for the Substations and Relay Department here at PUB. We help manage the grid through our substations, which are connected to a series of transmission lines that encircle our city in a loop. After the electricity is generated by the power plant and other sources, renewables, they're distributed on a transmission line and brought to substations. We take the electricity from the substations and we transform it down to a manageable level that can be distributed to the houses so that the air conditioning and your TVs and electricity and everything works. We do that by managing the grid through protective devices which are connected to the grid, and we can distribute, control, manage, measure, do all kinds of really nice things with our automation and electronic devices to manage the grid. In a substation, we've got two big transformers out here which are connected through a bus up to a transmission line that you can see up behind us. Those transmission lines, you probably see them when you're driving around all over the city. They're all connected in a big loop, and that's how we keep the lights on at PUB. The grid, there's a tremendous amount of power out on the grid, 138,000 volts of electricity on the bigger transmission lines, in some cases 345,000. And the way we manage that is we use what we call instrument transformers that are connected or surrounded by into the conduit, the conductors, and we take a really large amount of electricity and we transform it down into a smaller amount of electricity, which we can then connect to a computer protective device to help manage the grid. We have some really large breakers out here. Over here, these little things that have what they look like triangle-shaped hats on them. Those are circuit breakers, almost exactly the same as the circuit breakers that are in your panel at home, where if you trip a breaker, it's a thermal device, you'll go in, you'll notice there's a little red flag or something, and you can reset it, and if the problem in your electrical circuit is gone, you can reset that breaker. We do something very similar, but on a much higher, more sophisticated level using computers that use ones and zeros to measure things and make decisions. This is a brand new state-of-the-art substation. We've got two transformers that are 28 megawatts each, which is 28 million watts. Probably between 1,500, 2,000 houses per transformer. So potentially this station could run a significant amount of community. For a city the size of Brownsville, this is our 16th substation. So if that gives you sort of an idea of how we can distribute. Oftentimes, a lot of it's redundancy. We're not at 100% capacity at any of them, and we can take one down for maintenance and testing and use the capacity of another one to supplement that. The equipment outside is very similar to what we've been doing in the industry for many, many, many years. There's aluminum infrastructure with transformers that are copper windings with oil inside, but the significant differences are inside the substation, and we'll show you some of that here, where we're able to manage the electricity for not only to protect the grid against faults to help secure safety of people, the equipment, but we can also manage things to keep the lights on or transfer loads and do things much quicker using computers and very sophisticated stuff. We've got some really nice state-of-the-art stuff in the equipment in this station, which we're excited about. So here in our substation, inside the substation is where we have our control devices, the electronic relays that are the computers that control the circuit breakers. We're able to use the data that these devices collect to manage the grid, whether we have to open a circuit because there's a fault, whether we need to manage some data for any kind of management, to redistribute load, to help manage where our load is going. These devices are very smart. I like to tell a lot of people that everybody's heard about the smart grid. There's not really such a thing as a smart grid. There's such a thing as smart people that program these relays and build them. And it's the wave of the future. These are very state-of-the-art relays. They've got actually touch screen, just like on your phone now, where we can navigate and get information out of them very quickly. Our technicians can come in, and if there's a situation where they need to make a quick decision or manage something in a hurry, they can do that very efficiently. As opposed to the old days where we have some gauges over here from maybe 30, 40 years ago. We still use some of the gauges as a redundance or fail-safe technique to measure something. So in closing, we're happy that you joined us virtually. We're kind of sorry that we usually do these tours in person, and we've had some university students. There's lots of very interesting questions which sometimes help with this. So if you're sitting and watching and you have some questions, get a hold of Ryan or somebody at PUB. They can put you in contact with the right people or myself, and we're happy to discuss it, and we're excited about what we do here. We're happy to share the information, and of course, we're looking for talented recruits for PUB. Thank you.
You can see that it takes a massive infrastructure to provide the electricity needed to fuel a city like Brownsville. Now, with that infrastructure throughout the city, you need people who can not only maintain it, but can repair it if necessary. So that takes us to our last stop. Get ready to look upward to get a little bit of a sense of what BPUB's line crew does for us every day.
Good morning, I'm Eliazar Torres. I work in the construction and maintenance department. In our department, we do a little bit of everything. We set different sizes of poles, ranging from 120 to 35-foot poles. We also work with a lot of transformers, overhead and underground. In some cases where we have to replace transformers or work behind the yards, we don't have any access, we would need to access somebody with climbers. We do that with either with the climbers, or we have like a machine that we call an easy hauler to go back to replace the transformers. Also here we do the Herman rescue on a yearly basis. You know, in case it does happen in the field, we have one of our certified linemen that's going to do a little presentation in a while do the Herman rescue. So in this demonstration, it would be to bring the dummy down, in this case, to bring it down to the ground, and the body does weigh around 250 pounds. So we do this on a yearly basis, you know, from an apprentice to the lineman. In case if it does happen, say if somebody's up there, if it's really hot, you know, if some people can hydrate up there, so and they can't move anymore, so we bring them down. That's what it's really important to practice on a yearly basis in case if it does happen. Or in this case, if somebody gets hurt too, gets shocked or whatever, that they can't move anymore, we have to have somebody, you know, go up there and physically take them down. So right now we have a demonstration. We have one of our linemen that's going to do the demonstration to do the Herman rescue. And the tools he has, well, he has his climbers, his belt, and we just got a new belt maybe like 2-3 years ago, which is called a super squeeze. In case you slip off the pole, it'll choke the pole and you won't fall all the way down. And this, he needs his, of course, his belt, his climbers, and a hand line to tie. In this case, it's going to be the dummy, but out in the field, it would be one of the employees or one of the co-workers bringing them down off the pole. So he's going to do a little demonstration right now of bringing the dummy down off the pole. There used to be 2 minutes, but now with this new belt, I mean, there's actually, we don't have a set time right now, as long as you bring him down safely, and of course the safety of the guy. If he does it safely, you know, the person that's going up there does it safely, you know, just bring him down, you know. That's what we also, so when somebody's gonna climb the pole, we have what you call a spotter. Having these climbers, all this gear set up next to the pole in case it does happen, they're ready to go, take them down if we need to. The climbers themselves have what they call gaps on each side. Your left and right climbing gear. Stick into the wood, but before they have to have a certain angle. You just can't put them in straight. You have to put them in a certain angle. That's what they did give us a climbing course that we took. That's what they train you, how to do it the proper way. Just the belt itself with all, the hammer, all your tools, you're talking about 30 pounds. Well, these are some of the tools we use in our department, the electrical department. He's wearing some rubber gloves with their special. They're rated for 26,000 volts. Our voltage ranges from 12,470 to 7,200. This is also called a shotgun that we use. This is to use in the underground department with our URD transformers. He's also wearing a face shield. That's in case there is an arc, that'll protect you from either getting a flashover on your face or your neck area. He's also, our uniforms are FR rated. And he's also wearing the lanyard for the bucket that attached to one of the buckets. So in case in an event that the bucket does come loose, he won't fall down. We also wear steel-toe boots and of course our hard hat and safety glasses all the time. Our gloves, we get them tested every 6 months. Our equipment, we get them tested yearly. And if they don't pass, we either dispose of them and we order new ones. Thank you for joining us today. Make sure that if you see a power line down, make sure you keep your distance, keep away from it. Call either Brownsville PUB or 911, and they'll send the proper personnel to go out there and make sure that, just stay away from the wire. Thank you.
A big thank you to all the BPUB employees who helped out with this tour. It is the dedication of these local employees that really sets public power apart. Now let's use the distance that we currently have to our advantage and head on out to Hebronville, Texas, where the answer, my friend, really is blowing in the wind. Electrical generation. It's ever evolving to meet the public's needs and keep up with the progress of technology. From the beginning days of electrical service in Brownsville, when diesel was used to create electricity, through to the use of coal and then natural gas, Brownsville has witnessed many changes, and the Brownsville Public Utilities Board is taking a step toward more change, as it will now harness the power of wind to create electricity with the construction of the Sendero Wind Farm. Wind energy has seen tremendous growth in the last few years. According to the U.S. Energy Information Administration, wind capacity grew by 8% in 2014 and was forecast to increase by 13% in 2015 and by 14% in 2016. After waiting for the right opportunity, this represents BPUB's first foray into renewable energy.
The Brownsville PUB is very excited as the Sendero Wind Project reaches its commercial operation date. For a number of reasons. This is our first, as you mentioned, our first wind resource, but it is a resource that's being constructed by a really strong partner, Exelon. We couldn't be more pleased with how successful they've been developing wind, not just in Texas, but throughout the country. So we're excited. The project's coming to completion and can't wait to receive the power to deliver to our customers.
The Sendero Wind Farm in Hebronville, Texas is now online and bringing power to Brownsville residents. Located on approximately 20,000 acres in Jim Hogg and Zapata counties in South Texas, the facility was constructed by Exelon Generation and is their 11th Texas wind project. The wind farm is capable of producing 78.2 megawatts of electricity. According to ERCOT, 1 megawatt is capable of powering as many as 200 homes during peak demand. While the facility is located miles from Brownsville, there are certain advantages to this location.
This location is ideal because the wind comes up about the same time that the load on our system comes up. The wind patterns that you have here are very close to what you see in a coastal environment, but you don't have the corrosive nature of the wind. You don't have to worry about hurricane damaging the turbines. It is situated in a perfect location with regards to that.
There are 39 GE turbines installed at this location, each one capable of producing 2 megawatts of electricity. These turbines represent a significant increase in performance over its 1 megawatt predecessors. GE's 2.0 megawatt 116 meter rotor wind turbine offers a 27% increase in swept area when compared to the 1.7 megawatt 103 meter turbine, resulting in a 26% increase in annual energy production. This increase in blade swept area allows greater energy capture and improved project economics for wind developers. The intelligent design allows the wind turbine to adjust to wind conditions. GE's patented advanced loads control reduces loads on turbine components by measuring stresses and individually adjusting blade pitch. And the top of the turbine is actually able to swivel to be in the best position to catch the wind as it blows through the area. Let's look at some of the main parts of a turbine. The first is the most obvious, the rotor. The rotor includes the 3 blades used to capture the wind's energy. The wind creates a pocket of pressure as it passes behind the blade, causing the turbine to rotate. The nacelle looks similar to a box that sits atop the tower and is connected to the rotor through a series of gears. The nacelle houses a generator and gearbox. As the generator spins, electricity is produced. The tower stretches 80 meters tall, which converts to an impressive 262 feet. The towers have ladders running up the inside so that people can work inside them. As the wind blows, the blades spin clockwise and energy is captured. This causes the main shaft, which is connected to a gearbox within the nacelle, to spin. In turn, the gearbox sends the energy to a generator to convert it to electricity. That electricity is then sent down the tower to a transformer, where it is converted for use on the electrical grid and delivered to the residents of Brownsville.
The future for BPUB is very bright. With SpaceX coming into our area and other industry coming to develop, our demand will continue to grow, and we will continue to look at opportunities to add to our portfolio, to diversify that portfolio with either battery storage or solar panels is definitely on the radar. We look at that and evaluate that to find the point in which the economics make sense for us to purchase a solar resource.
The Brownsville Public Utilities Board has always elected to control its own destiny, choosing to produce its own power rather than just relying on the open market. The addition of wind energy represents a further strengthening and diversification of BPUB's energy portfolio, making the Brownsville area even more attractive to businesses looking to find a home. With eyes always on both meeting the city's demands and providing the infrastructure to grow, BPUB will continue to seek out the best opportunities to power Brownsville today and well into the future. Thank you for joining us today for BPUB's first virtual community tour. If you're joining us live, we're going to open things up to subject matter experts to answer any questions that you might have. But whether you're joining us live or after the fact, we hope that you'll decide to come and join us for an in-person community tour in the future. On behalf of the Brownsville Public Utilities Board, I'm Ryan Greenfeld. Thank you for joining us.